Hello, hi, my dear year 10 chemistry students. Okay, so this is a video of our next lesson. Unfortunately, I'm unable to come online due to my um, um, data connection. I'm always fluctuating between something like 1 bar and 2 bar. You can see again, it's just between that. Oh, sorry, wrong side. Yeah. So Maxis is particularly bad in this area, and I've been wanting to get a unified line and probably change my phone data to DG or something. But anyway, nothing can be done now with the lockdown. So alternatively, instead of going online and teaching you all online, I'm going to do these lesson videos, and then I'm going to share, upload these videos on YouTube and share the link through Google Classroom. You can watch it as many times as you like. I will take questions on the video through Google Classroom's comment section, or you can shoot directly to me through Telegrams. You just write to me your questions. If I think it's simple enough to be answered directly, I'll answer it directly. If it's very complicated, I will give you a call as soon as I can, so we can discuss over the phone. So this is how our lesson is going to be. It's going to be through video, and then there's going to be work assigned through Google Classroom, and then of course I'll be answering your questions through Google Classroom comment section, as well as we can also do Google Hangouts chats, Telegram chats, and of course phone calls. I will be calling you. You don't have to call me. Okay. All right. So this is just I showed you my face just to prove it's me. Okay. All right. So don't need to see my face anymore. Okay. So today's lesson is it's our Unit 4. So if you're wondering what is Unit 4, Unit 4, just an example. You know what this is. What am I writing? I'm essentially writing a chemical equation. This whole thing that you see on the screen is a chemical equation. But what makes up a chemical equation is this little units that we call as chemical formulae. Now, I know you must be wondering, wow, what a bad handwriting. Yeah, I know my handwriting is particularly bad when I use this particular app and pen. But don't worry, I have slides, so I'm going to go into slides and then I'll be scribbling over the slides. So essentially, you're going to learn how to write chemical formula. That's the focus of today's lesson. And then there's some practice that you have to do, and then you have to submit to me. And then the second part of the lesson, which is going to happen next week, according to the schedule, we will be looking at how to write equations, full equations, and how to balance them. All right, okay, so this is our lesson for today. Going on to, okay, so first, what is chemical formula? Essentially, chemical formula is a very useful shorthand when we are describing a particular reaction. So what can I learn when I read a chemical formula or a chemical equation? I can learn, hang on, I'm just gonna pick up the pen and scribble on it. Now, don't worry about the slides. I'm converting the slides into PDF, and you will be able to download it through Google Classroom as well. And this is a video, so you could actually pause and read. You don't have to, not necessarily have to keep up with it. Now, when you read a formula, for instance, this that I'm underlining here, that's a chemical formula. So what can I learn when I see chemical formula? I see that it can contain iron, I see it contains sulfur, and I see it contains oxygen. It also gives us information like there is 1 atom of iron, there's 1 atom of sulfur, and there's 4 atoms of oxygen. On this side, same thing. You could see formula, and it can tell you a lot of things about the what kind of atoms and what is the number of atoms and how they are arranged in a particular chemical structure. Now, this is an organic atom, so you're still quite far away from learning organic chemistry. But an organic substance is a substance that essentially has carbon as its backbone. Now, you can see the arrangement. The arrangement, when you learn organic chemistry later, you will know that there is something called functional group. In chemistry, when we look at this, we know that this particular chemical that you see belongs to an alcohol family. And so on. So you'll learn all this functional group a lot later, but for now, this is just why do we write chemical formula. Okay, it's a useful shorthand that we can use to understand about atom arrangement and its the elements that make up a particular chemical compound. Okay, now how do we write chemical formula? That should be our focus. At the end of this lesson, while you're practicing, you're going to pick up the skill of writing chemical formula. Now, essentially, how do we write it? This is just some steps. First step is, of course, you need to be able to write down the element's symbol. Now, where do I get symbol? Symbol is available in periodic table. You will have access to periodic table. But just for this practice, you could use a periodic table in addition to the common ion table that I've included in this slides later. Now, you will write the elements. If you're wondering what on earth is radicals, radicals are just elements in a particular state. You don't have to worry too much about it now because there is no reaction that you're going to learn in chemistry IGCSE that would include radicals. Higher levels, yes. Yeah, higher organic reactions, you will learn what is a radical. Now, once you've written down the elements, you have to write down the valency. Now you're wondering, where do I get valency? For practicing sake, you can refer to the table given. You can refer to the periodic table to sort of figure out the valency. But as you go along, you're expected to get used to the valency and remember it. It must be something that is of your memory. Now, there are some tips and that can be used for valency. Such as, for example, if I take periodic table, so I'm just gonna pardon my drawing. It's a little hard to draw using this particular device that I have. I mean, it's not hard, I'm just not good at it. All right, so there's group one, and then there's group two, and then you would have group three, and then you would have group four, group five, group six, group 7 and 8 and so on. Now, very simple. If it's metal, for instance, if you're an element in group 1, then you will have a valency of positive 1. If you're an element group 2, you would have a valency of positive 2. If you're an element group 3, then you would have a valency of positive 3. Again, now how about the others? So group 4, it's valency of 4. But you have to be careful here because these are non-metals. Non-metals essentially do not really form ionic compound on its own. They form an ionic compound in combination. But if it is a covalent compound, then the concept of valency does not apply. Now, you remember covalent compound from your previous lessons. These are atoms that combines in order to form a compound, like they share electrons, if you remember, whereas an ionic substance would form positive ion that's attracted to negative ion. I hope you still remember those lessons. If you're group 15, group 5 of 15, here your valency will be a negative 3. Here the valency, if you're group 17, your valency will be negative 2. And if you're group, 15 is negative 3, group 16 is negative 2, and group 17 will be negative 1. If you remember this, if you notice, these are the numbers that we need to make an octet. Because if you're group 15, your valence is 5. Then you gain 3 to become 8. If you're group 16, an example is oxygen, you gain 2. And then you become octet 8. And if you're group 17, like chlorine, you gain 1 electron, you become 8. So their valency is sort of related to their group. So you don't really have to memorize this. As long as you understand this concept, you could just refer to the periodic table and make a judgment on what the valencies are. But this cannot be applied to all element there is. For instance, the transitional element that sits in the middle here, they are very unique. For instance, iron, it's 2 plus, and some ion is 3 plus. Yeah, so these are the examples that you have to remember. You have to take an effort to remember because this would be given in the common ion table, but it will not be given in exams. So you have to get used to it and you have to memorize it. And then there are unique polyatomic ions like sulfate and chlorate and so on, which I'll talk more about later. But you have to get used to them, and then you will have to remember their charges. That would be your only challenge. but if you spend some decent time practicing and studying it, you will get used to it, and after a while it becomes reflex. It's almost like writing a sentence in English. Okay, so once we have written down the elements and their valency, for example, I'll just do one above here. First I write, so if for example, question is asking me to write the chemical formula of sodium chloride. So first I write this element, sodium, and then the valency being positive. And then I write the element chlorine, because it's chloride, right? So negative. Next step is you cross them over. Now what does it mean? You cross them over, you bring this down here, and you bring this down here. Now it's, keep in mind, it's +1 and -1, so that means now it will be Na1 Cl1. Okay, now what we do is we'll take the simplest combining ratio and we'll cancel them, which means these are both ones, which means I can cancel it. That means my final answer is NaCl. Okay, so of course if it has more than one valency, then the name of the compound will indicate, which means we do have to talk about naming a bit, and I have that coming up later, because writing chemical formula means you should be able to understand the name of the compound. Like for instance, when I read the name sodium chloride, that means I know it's Cl. Chloride is Cl, even though as an element we call it as chlorine. Okay, so of course more examples coming. Sodium sulfate, you can see how in this case sodium has got a +1 charge, and sulfate I'll just write above here. All right, so if I do Na plus and then it's SO4 2-, and we can cross this, so it's 2 and 1, and then we can, the thing is you can't cancel them. It's 2 and 1, so it can't be cancelled. It doesn't have a common factor. Therefore, 2 will remain. 1 is not something that we have to show. But in reality, if I have to show the 1, then it becomes, I need to bracket SO4 bracket and I put 1 here. But these two cannot be essentially cancelled. Right? So because it's 1, we don't have to show, so we just write Na2SO4. Now same thing here, it's calcium Ca2+, hydrogen carbonate ion has a charge of -1. So it becomes 2+, 2 comes over here, 1 goes over there. As a result, we essentially, so if I were to show you here, it's 1 and that's 2. That means this is 2+ and this is -1. Okay, so you would have seen a trend, like you can always see how the positive ion is always on the left and the negative ion is always on the right. Now if you're wondering, oh my god, what is hydrogen carbonate ion, how am I supposed to know what charges is? Like I said, there is a common ion table that you will have to take an effort to remember, and some of these ions, because they are quite common in our syllabus, they'll come quite often around, so you will get used to it. So this is the common valency, so charges, we call it charges, and you can see these are the common ones. Again, no such table will be given in exam, so you just have to get used to it. Some of the ones that, like what I've mentioned before, you can't relate to their group, will be ions like zinc, even lead, iron. These are transitional metals. The rest, I think it's quite straightforward. I think in silver is not according to its group, but you can see hydrogen is in group 1, so it's technically +1. Sodium is in group 1, so it's +1. Lithium is +1. Ammonium is not in any particular group. This is a compound, so NH4 +1. Barium is group 2, calcium is group 2. Copper is a transitional metal, again +2. You have to take an effort to remember. Magnesium is in group 2, so it's 2+. Aluminium is in group 13, so it's 3+. Some negative ions here. Group 17 chlorine, so it's -1. Group 17 again -1. Group 17 again -1. Group 17 again -1. Hydroxide not in any particular group because it's a compound, also -1. Nitrate again not in any particular group because it's a compound, -1, and so on. So sulfate, carbonate. So some of the ones that we already talked about before this, like hydrogen carbonate ions and so on. Like I said, as you go along, you will get used to more. Again, at the end of this lesson, you are required to complete a worksheet for me. You may have to go up online and do some research because not all ions is included in this table, or I've talked about it. Some you may have to go online and look for it, especially the rare ones. But don't worry, it's just a practice generally for exam. The common ions is what we are looking at the screen here, in addition to some that you might get used to as we go across the syllabus in this next 1.5 years. Okay, so some naming. Now, naming is very useful. If you're not good at naming, then usually you are naturally going to struggle with writing down the formula. Now, you have to remember that while you may not be asked to name, but you could be asked to write down word equation, which is essentially using the name. And you might be asked to, of course, write down the chemical formula for a particular name. So this is why naming plays a crucial role in this. Now, some basic rules. Again, we are not going to talk about all the compounds. There is I'm not going to talk about organic compound because we are not in that part of the syllabus yet. So these are the common compounds that we will come across. Any elements essentially that is in combination with oxygen will be given a name. So you can see like this, I see a sodium, I see an oxygen, I see a calcium and oxygen. We will give it the name oxide, which means behind the word oxygen, we will remove Y-G-E-N and we add I-D-E. So it becomes sodium oxide or calcium oxide. And then here is, of course, this is chloride, so automatically we know the element chlorine is in position here, so it becomes a chloride. You see the word bromide, it's basically bromine, and iodide is iodine. So I think you can see a trend here. This is chloride, bromide, iodide, they're group 17. Hydrides, when you see hydrogen in combination with metal, you can essentially call it hydride. Nitrogen it becomes nitride. So you have to take an effort to remember this. Other naming of compounds. Hydroxyl, this is a group that's called hydroxyl, but when it's in combination, so you see when it's just OH, it's hydroxyl, but when it's in combination with a metal, we call it as hydroxide. So you can see this is a calcium hydroxide. And then this is CN, it's a cyanate ion, and it becomes a potassium cyanide. I think it's safe to say you might not see potassium cyanide in your syllabus across, but it's something good to know. More names, again, chlorides, but what is this Roman numeral in the middle here? Now this Roman numeral represents the charge of the metal. Now, you must be wondering, why didn't I see it? For example, I'm writing sodium chloride. Why isn't there a Roman numeral in the middle here? Simple, because sodium do not have any other charges than +1. However, transitional metal, if you can see, this is lead, Fe, iron, and this is mangan. Transitional metal elements, which means they are generally, if I draw the periodic table, they're generally found in the middle section here. So they are generally found in the middle section here. This is where they are found. They tend to have more than one, what we call as an oxidation state. If I were to put it in simple words, they could possess more than one charge. So you'll understand that better a lot later when you learn transitional metal, but at this stage I just want you to remember they could hold more than one charge. For example, here you see this is lead 2 chloride. So lead 2 chloride means it's Pb2 plus, whereas here is lead 4 chloride, which means it will be Pb4 plus. Simple. All right, so the Roman numeral in the middle here will tell us what is the charge, because if I don't and I just tell you lead chloride, that means you could assume any charge you like. Or more commonly, people tend to just assume it's 2 plus because that's the most common ion for lead. Very rarely they're going to think that it's 4. So if we want to be more specific, when we are discussing chemicals, when we are telling someone you have to use lead 4 chloride, then means we are telling them the lead in the lead 4 chloride has an oxidation state of 4, or it holds a charge of 4. And you can see how chemical formula changes because of that. Because if I'm writing Pb 2 plus Cl minus, that means it just crosses over, 1 comes here, 2 goes down here, and it becomes PbCl2. But if I'm writing for PbCl4, and this is positive 4, and this is Cl negative 1, and this will cross over here, that will come over there, and it becomes Pb1 Cl4. 1 is not something we have to show, but you know, it's not wrong if you write it down, but it's not something we do. So you can see PbCl4. And same here, iron 2 hydroxide, because iron tend to have an oxidation state of 3 or 2. So this is iron 2 hydroxide. If I'm writing iron 3, then the formula would differ. It goes like that. See, that's because the iron inside this is an iron 3 hydroxide. All right, manganese 2 hydroxide. You will not see this Roman numeral for group elements in group 1, elements in group 2, elements in group 3. It's only unique for those that exist in the middle here, called the transitional metal. Okay. Right. Next, other naming of compound. Sometimes when you have more than one atoms present in it, we could include a prefix that will tell us the number. Which means when you see the word mono or mon, that's referring to one atom. If you're looking at di, that means there's 2. So carbon monoxide is CO. Carbon dioxide is 1 carbon and 2 oxygen. Sulfur dioxide, 2 oxygen. Sulfur trioxide, that means 3 oxygen. So if you come across di, tri, that means it will tell you the number of oxygen that's present inside of it. You can ignore this part. We don't have to worry about the oxidation state yet, because this is generally done in year 11, where we learn the redox numbering of the elements. Now PCl3 again, phosphorus, and I see 3 chlorine, so it becomes trichloride. So you see tri here, it indicates 3. Phosphorus pentachloride, that means penta is 5. So the numbering for chemistry, as far as chemistry goes, mono means 1, di is, okay, so this is 1, this is 2, tri means 3, tetra means 4, penta means 5, pentagon, 5 pointers, you know, if you remember that. Hexa means 6, hepta means 7, and it goes on, but you rarely for IG that will go beyond 5. But it goes on, there's octa, there's nona, deca, and so on. All right, more naming of compounds. So now, if a metal contains, if a compound contains metal and non-metal, and it has oxygen, right? Like for example, carbonate. So you see, there's carbon, there's oxygen. We normally add the ATE at the back. Now, keep in mind, you're not going to be asked to come up with these names, but you have to get used to these names. So when you see the word carbonate, that means you see ATE, it simply means there's carbon in combination of oxygen, and it becomes a non-metal ion, all right? So now, for example, a sodium carbonate. So if I see the word sodium carbonate, I know there's sodium, there's carbon, and there's oxygen in it. All right, so we put the word ATE at the back. So carbonate, sulfate, nitrate, very common ion. I need you guys to get used to this. I believe it's already in that list. This has a charge of 2 minus, this has a charge of 2 minus, this has a charge of -1. All right, so these are the charges. So you might be familiar with this: sodium nitrate, magnesium nitrate. You can see how sodium nitrate is NaNO3. Why? Because they're +1, -1, so they can sort of cancel off each other. Magnesium is 2 plus, whereas nitrate is -1, so they can't cancel off each other, so it becomes 1 we don't show, 2 we have to show, and since this is more than one atom and you have a number here, so you have to bracket it. Same goes here. So you can see 2, because sulfate has a charge of -2. Iron, this is an iron 3. I can see iron 3, that means this is 3 plus, and that can cross to give us Fe2 bracket SO4 3. And this is iron 2 sulfate. That means this is 2 plus and 2 minus, so they naturally cancel off each other. Okay. All right. So this is just to summarize. In summary, you can see common name is sulfate, so that will be the formula. Don't worry about systematic name. Systematic name is not really going to be appearing anywhere in our syllabus, not even in exam, not anywhere. But these are the names that, common name is the one that you're expected to get used to. And these are ions that are not very, very popular for us, but what's very popular is sulfate, sulfide, nitrate, and nitrite. These are the common ones, very, very common. It's good to know their formula, and the charges is available in the common ion, and wherever it is not, you can look it up. Okay, all right, so that's the end of this lesson. So what I need you to do now is please go to Google Classroom and then download the worksheet. It's called Unit 4 Worksheet 1, because obviously there's more worksheets to come. And then I need you to practice. Essentially going to write down formula. The names of the compounds are given. You will write down the formula and then take a picture of your work. If you have a scanner, you can scan and email to me. If you don't have a scanner, that's fine. Take a picture. Make sure the picture is clear enough so that I could mark on it. And then you email it to me at mohan@egis.edu.my. If you don't have to print the worksheet, all I need is the answers, but make sure the numberings are correct. Follow the numbering. Please write clearly. Some of your handwriting, I have a hard time reading in person, and I'm going to read it through an image. Make sure the image is bright enough. Make sure the image is clear. Make sure I can see your handwriting, which means please use a bright pen or something very clear, very dark. Please try to make my life a bit easier. Deadline for submission of this work is 4th of April, which means I'm hoping you can go through this lesson today. Sorry, according to our SDS, our lesson will be on Friday, so you can go through this lesson. And then you have about 2 days to submit the work to me. And then I'm going to have to mark it and try to get back to you before our next lesson, because our next lesson is on chemical equation, and it's very important that you're able to write chemical formula. Only then you are able to write a chemical equation. Okay? All right, so if you have questions on this lesson, you can write it in the comment section of Google Classroom, or you can drop a message in our Telegram group. I'm encouraging you to ask questions in the group rather than in a private message, because then when I'm answering you, probably your classmate would be able to learn something from that, or maybe they have the same question, so I don't have to answer the same question more than once. Okay? All right, thank you. Have a good day. Stay healthy. Stay safe.